Okay, you guys, these problems right here, let me just go over it. I just want to make sure you guys know how to put this in your calculator. First of all, 55 degrees, what mode should I be in, you guys? Degree mode. So everybody hit your mode button. Whoops. Okay, degree mode. I go back here. And all I have to do, how do you put cosecant in your calculator? 1 divided by the sine of 55. 1.22. Cosecant is defined to be 1 over sine, right? Okay, what would I put in for cotangent? 1 divided by the tangent of 70. And what would I put in for the third one? Exactly. I got to change my mode back to radians because it's in radians. And what do I put in my calculator? Tangent of 5 pi divided by 12, 3.73. How many of you had all of those? Good job. Okay. All right. Now, I am prepared to answer questions. A couple questions on 6-8, things that you're not understanding. Let me remind you, when I give an assignment like 6-8, I gave it to you on Wednesday, right? I gave it to you on Wednesday, and it's not due till Tuesday. So I'm giving you almost a whole week to do them when I do those times. My expectation there is when you guys come back to class today that you have tried all the problems, and the ones that you don't get, those are the ones I answer questions for. Here's the problem. If you guys don't do 6-8 and procrastinate because you think you have till Tuesday, then you don't even know what questions to ask. You haven't studied out in your mind, and you really don't understand it that well. And so when I answer questions, it doesn't do you all that much good. You need to try all these problems before you get to class, okay? All right, Callie. And turn it in the next class. What number? 22. What? No. Hey, you guys, listen. I'm going to... Okay, let's do 29. Tell me what that one is. Cosine, parentheses. Sine inverse of what? Cosine inverse of what? Okay, I probably didn't need that inside parentheses. Now, because there will be some problems like this on the test. Okay, so I taught you how to find each individual thing. You guys should know how to use order of operation to get something like this, because you've been doing this since you've been in pre-algebra. So but I taught you how to find cosine inverse of 0, haven't I? That's what we did last time. So what is the cosine inverse of 0? You know, you guys, I want everybody on your 3x5 card, I want you to write this. If you don't have a 3x5 card, write this in your notes, okay? When finding an inverse, you are finding, it's probably not the best way to say it, but you are finding an angle. That's all we're looking for when we're finding an inverse, is an angle. So in that thing up there where it says cosine inverse of 0, here's an example. I would write this down in your notes too. Cosine inverse of 0 means cosine of Cosine of what angle sorry, put that cosine inverse of did it again. Cosine inverse of 0 means cosine of what angle is 0. That's what it means. Cosine of what angle is 0? We're looking for an angle. That's the key. What angle gives me a cosine of 0? Now, everybody go look at your unit circle chart. Everybody go to your unit circle chart and tell me cosine is defined to be what on the unit circle? The x-coordinate, right? If you don't know that by now, if you don't know about it now, you're going to be in trouble on the test. You got to know that on the unit circle, the cosine is defined to be the x-coordinate, and the sine is defined to be the y-coordinate, and the tangent is y divided by x. If you don't know that, you're in trouble, because that's what this whole test is on. On the test, I will leave these unit circles up here, and I'm going to let you use this that I gave you last time. Got it? I'm going to show you all the key information on there that you need to use. Yes? Yes, if you want. Okay, now look. You guys, cosine of what angle is 0? 90 degrees, but we're going to do this in radians. So pi over 2, okay? So we go over here, and we're going to replace the cosine inverse with pi over 2. That's what cosine inverse of 0 is. It's pi over 2. Got it? Why don't I take 270? Oh, hey, you guys. Remember that cosine inverse? Remember all the inverses we had to restrict to get their range? We had to restrict the cosine, sine, and tangent functions to find its inverse. And so, and to find an inverse, you switch the the domain and range. And so remember the cosine inverse was defined to be in the first and second quadrant between 0 and pi. Okay, so the reason I don't take 3 pi halves on that, because 3 pi halves also has a cosine of 0, is because it's outside the range. Remember, cosine inverse is only in the first 2 quadrants. Got that? And where's the sine inverse located? In 1 and 4 quadrant, but if it's in the 4th quadrant, you have to get there by going in the negative direction. Yeah. So everybody go to sine inverse of 1/2. What angle has a sine of 1/2? 30 degrees, right? Which is pi 6, because sine is defined to be the y-coordinate. The y-coordinate is 1/2 at pi 6. So sine of pi 6 is 1/2, right? So right here, pi 6 is what I get there. Now, I need to add these two numbers together, pi halves and pi 6. In order to add fractions, you have to have what? Common denominator. So what is my common denominator of 2 and 6? 6. The one on the right doesn't change, does it? Its denominator didn't change, so its numerator's not going to change. What did I times 2 by to get 6? So I got to times the top by 3, and what am I going to get? And if I add 3 pi 6 plus pi 6 together, I get 4 pi 6. 4 6 reduces to 2/3 pi, right? 2 pi over 3. So coming back over here, this is we're asking for the cosine of 2 pi over 3. Now I go back to my unit circle. Cosine of what angle is 2 pi over 3? No. 2 pi over 3 is an angle, just like 120 degrees is an angle. This is the same question as asking, what's the cosine of 120 degrees? Yeah, cosine is asking me to find the x-coordinate, which is negative 1/2, and that's my answer. Got it? Do we kind of get that kind of a problem? You're going to have to practice a few of them. All you're doing is replacing cosine inverse of 0 with what its value is, and then sine inverse of 0 with what its value is, pi 6, adding those two together, and then finding the cosine of that 2 pi over 3, which is negative 1/2. Nicole, let me answer some of these guys' questions. Why didn't we use degrees? We can use degrees. You guys, I could have gotten degrees and got the same answer. Pi halves is 90 degrees. Pi 6 is 30 degrees, right? And 90 plus 30 is 120 degrees. And the cosine of 120 degrees is negative 1/2. So if you want to use degrees instead, you can. I just like you to use radians because when you get into higher math classes, if you know how to use radians, it's going to make it easier for you, and it's good to practice now. But on the test, if you want to use degrees, you can. Okay? We had to get a common denominator. And see, the common denominator is 6, right? What do you times 2 by to get 6? So you got to times the top by 3. Got it? Okay, any other questions? Well, you guys, it's like I said, most math you learn in high school is to help you practice using your left-sided brain, okay? But there are fields that use this. Surveying would use this a lot, tons. If you become a surveyor, you do tons of this stuff, okay? Engineering, because engineering and surveying are very connected, you would use it a lot. Those are probably the two fields you'd use it in a lot. There are some of the sciences that you might use it in. Physics, you would use it in physics for sure. If you become a physicist, okay, you could do that. I don't remember. Hey, you guys want to do another one like that? What? 26. Okay. What does this one say? 2 what? Sine of 2 cosine, right? Sine, parentheses. Like that? Okay. You guys, on this one right here. Okay, this one right here. You always start in the inside of the parentheses. Always start with the inverses, the cosine, sines, whatever's inside. So, I'm going to ask Callie, what is the cosine inverse of square root 2 over 2? X. Huh? I'm asking for the cosine inverse of square root of 2 over 2. No, because look at pi force. That's pi force. What's the x coordinate? No, the x coordinate. You have an x and a y coordinate. Yep, that's it. You guys, cosine inverse is saying what angle has a cosine of square root 2 over 2? And cosine is defined to be the x coordinate, so it's pi force. So we go sine of 2 times pi over 4. Got it? Does everybody understand that? Okay, cosine inverse of square root 2 over 2 is pi force, right? Now, can I simplify this? Pi halves, because 2, we're going to that once and going to that twice, right? So it's the sine of pi halves. Imari, what is the sine of pi halves? Sine is defined to be which coordinate? The y coordinate. So go to pi halves, find pi halves. Sine is the y coordinate. What's the y coordinate there? 1. Got it? Do you understand that? That part? Do you understand this part? Cosine of, well, this one wants to know is what angle has a cosine of square root 2 over 2. So you go up there and you look for all the x, because cosine's the x coordinate. You find where the x coordinate is square root 2 over 2, right? It's pi force. And that's what it is. You got pi force. Okay? You got that? Okay? All right. Any questions on this one? By the way, when you do these kind of problems on your assignment, on the test, listen, when you guys do this on the test, you got to show your work. No calculators. I need to see your work. No calculators on this kind. You need to show your work. You can use it to reduce things or to find common denominators, but I want you to use the unit circle chart and that other chart, this table. That's what I want you using. I don't want you to use calculators. I need exact solutions. So if the answer is square root of 2 over 2 or square root of 3 over 2, you're not going to, if you used your calculator, you're going to get it all wrong, the whole thing. Okay? And if all you have is an answer down here, I'm not going to give you full credit because I expect you to show your work. Okay? I need to know that you understand what you're doing. By just writing down an answer doesn't show me what you know what you're doing. Okay? All right. I'll answer one or two more questions on 6-8 before we go on to 6-7. I'm not going to do both of them. I'll do one of them. Which one do you want to do? 28? What does it say, Mason? Oh. No, I'm not doing that one. Hey, I expect you to try this before you ask me, okay? Well, open your book. I've done a couple of them now that you should be able to do it, Mason. So try it. Cosine inverse tangent? No, cosine's not inverse, just tangent. Cosine times the tangent inverse of 1 minus the sine inverse of. Because I really do expect you to try these, okay? If I'm doing them all for you, you're not getting much out of them. In fact, I'm going to kind of pick on some of you right here to give me these things right here. I'm going to start with Brindley. Brindley, what's the sine inverse of 1? Huh? Okay, sine is defined to be the y coordinate. What angle has a sine of 1? Look at all the y coordinates up there. Where is the y coordinate 1? Huh? I think you said it right. 90 degrees. Okay? You guys want to do this in degrees or you want to do it in radians? Okay, we'll do it in degrees. It doesn't. As long as you're consistent with each problem. You don't want to put one in, like I don't want to do the tangent inverse in radians and this one in degrees. I want to do them in both. Okay, I am going to now pick on Adley. Tangent of what angle is 1? 45-degree angle, right? Because tangent is defined to be y divided by x. So the two coordinates have to be exactly the same. Where are the two coordinates exactly the same? At 45 degrees, right? So that's 45 degrees. Hey, everybody, can I borrow this again? You guys, everybody go right here. The reason I gave you this, there's some over there. Go grab them. Oh, no, I put them up here. Hey, you guys, if you'll notice, these are all on here. The problem is when you're doing inverses, you got to make sure that you remember to, if it's a tangent inverse or a sine inverse, and you're in the fourth quadrant, if you in the fourth quadrant, you got to go in the negative direction, okay? But you can use this table to find all those answers. Yeah, I said that. Huh? Okay, good question. Listen, 5 pi over 4. Why does 5 pi over 4 not work for this, you guys? Yeah, this is very important. Because 5 pi over 4 would give me 1. Okay, if you look on your table of values at 5 pi over 4, you'll notice the tangent of 5 pi over 4 is 1. Do you see that? But the reason it doesn't work is because my range for tangent inverse is quadrant 1 and 4, right? Quadrants 1 and 4. Okay, Dylan. Tangent's y divided by x. Yeah. Tangent inverses can be in the first and fourth quadrant. Okay. No, it can also be 30 degrees or 60 degrees. Just look at the tangent of 30 degrees. What is it? Tangent of 30 degrees on your table. $30 tangent, right? Square root 3 over 3, right? Well, I could have gotten that by going 1/2 divided by the square root of 3 over 2, but this is just faster using that, okay? All right, you guys, we're not done with this one. 45 minus 90 is negative 45 degrees. We got that? Now, where is negative 45 degrees? It's not on your table, is it? It's, instead of going up 45 degrees, you go to the clockwise direction 45 degrees. It's the same thing as 315 degrees or pi fourths. And the cosine is defined to be the x-coordinate, so the answer is square root 2 over 2. The x-coordinate is square root 2 over 2. And there's my answer. Okay, that's what you need to know how to do. All right, I am going to move on to 6-7 and answer a few questions, then we'll correct that and turn it in. I would make sure you look over these before the test so you know how to do them. The quadrants for the cosine? The quadrants for the cosine inverse is 1 and 2. Okay. Okay, let's go to lesson 6-7 and answer a few questions. And then we'll correct it. Okay, Emily? Okay, everybody get out your table again for 21, 22, and 23. 21, 22, 23. Okay, 21 asks you to find a value of theta for tangent of theta equals 0. I am going to look at my function. Now keep in mind, I'm assuming that this thing goes out to 4 pi each direction because like the sine function has 2 cycles. Well, it's not even quite that much. Every one of those tick marks is pi halves. So 2 tick marks is pi. 4 tick marks is 2 pi. Got that? Okay, if you're looking at this and it's asking me on number 21, is that the number tangent of theta equals 0? Okay, so I want to know for what x values or angle values, and I'm going to use this thing right here, is tangent 0. Well, guess what? I can just look at this thing right here, and I can go look at where an x-intercept is going to be where my answers are, right? Where's one of my x-intercepts? Because I want a y value that's 0. That's at the x-intercept. So where do my x-intercepts occur? Every pi, right? It starts at 0, then pi, then 2 pi, then 3 pi. It crosses. Can you see that? So my answer for that one is going to be multiples of pi. Beginning at 0. Do you want to put that? So any time you get to pi, 2 pi, 3 pi, 4 pi, 5 pi, and so forth, your y value is going to be 0. Does that make sense? Now, the other way you could do that, you guys see this table? Go to your tangent function. Find all the zeros for tangent. Go to your tangent column. Where's the first one? 0. Where's the second one? Pi. Where's the third one? 2 pi. That's another way you can get it, right? I purposely waited to give this to you until you at least tried to think about that other stuff. So, okay. So does that help you on those, Emily? Okay. All right. Are there any other questions? 28? Okay, 28. Find the value of theta for which cotangent of theta is undefined. Well, go pick up your chart again. Go to your cotangent. It's whenever that little infinity sign is. I don't know why they use that for undefined, but they should write undefined. So where is it undefined? At multiples of pi, right? You can also look at your graph of cotangent right here, and you'll notice that there's an asymptote at 0, one at pi, one at 2 pi, one at 3 pi, and so forth. Anywhere there's an asymptote, it's going to be undefined. Okay. Yeah. Any other questions? Okay, which one do you want to do? $32? Okay. That's 32. What does it say? Whoops, theta over 2. That's it? Minus pi over 4. Oh, you guys, look right here. I know that usually, I'm going to call that pi, 2 pi, right? 3 pi, so forth. Okay, I usually know, and I'm gonna do this in a couple different ways. I know that the tangent function looks like this, and there's an asymptote here, right? And then the next one's going to look like this, and there's an asymptote here. The next one's going to look like this. There's an asymptote here, right? That's what the tangent function looks like. Now, what's happened right here is there, instead of, and normal tangent period is pi, right? And remember that formula, period equals pi over k, because the period, it's 2 pi with sine and cosine functions, but the tangent is pi over k. And we know that k is 1/2, because really when it says theta divided by 2, it's 1/2 theta. So, and I know, so I'm going to have p equals pi divided by 1/2. If I invert and multiply, I'm going to get 2 pi. So now one cycle is going to take 2 pi to complete. So it's going to be twice as long. Yes, Jared? Oh, yeah. It is. I'm sorry. I'm going to go to the next page anyway, because did you guys catch that? I made a mistake. I did a decreasing function. It should have been this way. I didn't even do a cotangent, because cotangent is between 0 and pi instead of between negative pi halves and positive pi halves. So let me show you guys. What was that equation again? Y equals tangent. Oh yeah, theta over 2 theta over 2 minus pi over 4 plus 1. Now, a couple of things have taken place, you guys. What does the 1 do? It's a vertical shift. Good. Up 1 unit. What does the pi force do? It shifts it to the right. But remember, I need to figure out what the phase shift is. The phase shift is equal to c, which is pi force, over k, which is 1/2. If I invert and multiply, I'm going to get pi over 2. This graph is going to shift to the right pi halves. Got it? And one cycle, because I just figured it out on that last page, one cycle, what was it again? One cycle is now going to take place between 0 and 2 pi. So, right here, I'm going to draw a graph. Here's my x-axis. I'm going to draw, here's 1. I'm going to draw a dotted line around here. Because now my graph, this is the equilibrium point on there. Okay? It's the middle point. So it's going to shift up that way. I also know that this graph is going to shift pi halves. Here's pi. There's 2 pi. And there's 3 pi. I now know that this graph is going to shift to the right, phase shift of pi halves. And so now, this point right here, here's pi halves, is going to become the middle of my, actually it's going to be up here though, right along that line, right? It's going to be the middle of my, my graph. In fact, what I should do is, if it shifts over pi halves, see, and that one cycle takes place between 0 and 2 pi, and that's the middle of my graph, and it shifted it to the right pi halves, right? 2 pi. So I am going to need, so this thing's going to go like this, something like this. It's going to go, I know my asymptotes are going to be right here and right here. Is that right? Is that what your graphing calculator shows? Okay, it's going to shift to the left pi halves, and the new period is going to be a length of 2 pi, which it is right there. Callie. You had the what already? Uh-huh. To see the rest of it? Well, if I was putting this one in my calculator, I would go like this. Okay, let me see. I would, first of all, let's all have the same window. You guys have that window right there? Negative 2 pi to positive 2 pi, pi 4, negative 5 and 5 and 1. Okay, if I go right here to my calculator and I go tangent of 0.5 theta, because that's the same thing as 1/2 theta, right? Minus pi divided by 4. Ending parenthesis. I hit zoom 6. Did I do that right? Oh, I didn't do +1. That's not right, though. No, I don't want to hit zoom 6 because that'll give me a different window. I want to set my window. Oh, I did hit zoom 6. That is the problem. Why did I do that? Habit. Got to go back and fix my window. Uh-oh, what did I do now? Oh, I'm in my window. Okay. I'm really tired. Sorry, guys. Pi force. Thank you. That's why it didn't look right. Now it looks right. Okay. You'll notice right here at this pi halves is one of my asymptotes. At 3 pi halves is my other asymptote. So, in other words, a period takes place over a period of 2 pi. From negative pi halves to 3 pi halves is 2 pi length. This graph has been shifted up, so my equilibrium point's at 1 right there. And it's been shifted pi halves to the left, my phase shift. Okay? So anyway, did I answer your question, Callie? Okay. Sorry. I am so tired. I've not been this tired in a long time. Okay, here we go, you guys. This is the review. We're going to find the tangent inverse of -1. Okay? You guys, give me your answer in radians. You don't need your calculator for this. You need your unit circle. Radians. Yep, I want the answer in radians. Keep in mind it's an inverse. Keep in mind the range of an inverse. Keep in mind the range of the inverse. The answer is pi force because, negative pi force because I want the tangent inverse to be -1. And if you look down here at 7 pi force, okay, you'll notice that if you take the y divided by the x, it's the same number, but one's negative, one's positive, you're going to get a -1, right? But we can't call it 7 pi over 4 because the domain of the inverse, tangent inverse, is between negative pi halves and positive pi halves. So you have to go in the negative direction. So that's negative pi force. Okay? Yes? 3 pi out of 4 is out of range because it's not between, remember, here's negative pi halves and here's positive pi halves. It has to be in this area over here. 1 and 2. Anytime you're doing a tangent inverse, it has to be in 1 and 4. Okay, next one. Here we go. Correct. Everybody that's shown me is correct. The answer is pi. The reason why is if you go right here, hey, please, you guys, some people are trying to listen. Okay? If you go to pi right here, the cosine is defined to be the x number, and it's -1 right here, right? So the answer is pi. Well, remember, when we're doing inverses, we're looking for angles. Okay, next question. Convert 75 degrees to radians. Don't forget that this is on your paper, the back or the front side bottom left. The formula for converting. There will be 2 problems. One where you convert radians to degrees and one where you convert degrees to radians, and those will be the 2 easiest problems on the test. So you got to try to get these. Okay, we're going to take 75 and times it by pi over 180. And we're going to get 75 pi over 180. The only thing is we need to reduce the fraction. I can tell right now, since that ends in 5 and that ends in 0, 5 goes into it. I know 5 will go into 75 15 times. Yeah. And it will go into 180 36 times. I also know that 3 will go into that 5 times. 3 will go into 36 12 times. That's how I want your answer, 5 pi over 12. Any questions? Okay? Right here, convert to degrees. Oh. Correct. Okay, you have to times by 180 over pi. Those cancel out. 180 divided by 5 is equal to 36 degrees. There's going to be 2 problems like these. Okay, you guys, next question. By the way, you guys, the questions I'm asking you are going to be like questions on the test. Okay, 40 times, right? By the way, since they both end in 0, I know 10 goes in both of them. So 4 pi over 18, those are both even, so I know 2 goes into both of them. 2 pi over 9. Got it? Hi, McKinley. Come here. Okay, next one right there. Hold on. 2 pi over 7 times 180 over pi. Those cancel out. What does that equal again? 51.4? Okay. All right, there's one like this on the test. This is kind of like what we were doing on 3-8 today, but just think about those. No, you guys, you're evaluating, you're trying to find the value of it, but you can't use your calculator. You got to find cosine of 2 pi over 3 on the unit circle, times it by 3, find the tangent of negative pi over 4 on the unit circle, times it by 4, and then add those two numbers together. Okay, to do this one, you guys, we have to find the cosine of 2 pi over 3. So Callie, put a 2 pi over 3 over there. What's the cosine? Negative 1/2. Is that what you guys all got? Okay, Mari, tangent of negative pi force. Huh? No. Go to, where's negative pi force going to be? Down in the 4th quadrant. Well, that's the y coordinate and the x coordinate. Tangent's defined to be y over x. So it's going to be negative 1. Hey, you can look it up on your table. Okay, over here. You guys, look. Instead of positive pi over 4, which is up here at 45 degrees, you go down right here. And tangent is defined to be this, which is negative 1. Got it? You guys, this is negative 1.5. This is negative 4. You add them together, you get negative 5.5. Some of you guys wrote it in a fraction as negative 11/2, so either way works. Okay? Any questions on that? Show me your work on that. Show me what I just wrote down right there. Show me this blue and this red right here, and that's your work on the test. Okay? Yeah, we're going to review for the first little bit of class next time. Okay, let's do this problem. Find the function of the graph. Use the given window. By the way, this is negative 5 right here. My cursor was there when I made my screen capture. You guys, let me, just for the sake of time, let me show you the two answers those guys got back there. Sarah and Kyle, show me what you got. They got two different answers. Y equals 3 cosine of 2x minus pi force. That's Sarah's, right? And y equals 3 cosine of 2x plus. Yeah, second one's sine. Sorry. Hey, let me just show you how this goes. You guys, if you can find the amplitude and k just by count k, you can find by how many cycles take place between 0 and 2 pi. To find how far it shifts, you can just play around with numbers. But look right here. The tip, if this is a cosine function, usually the tip would be right here. And it shifted over here, and this is pi force. It shifted over halfway between 0 and pi force. Well, it's not going to be pi eighths is how much the phase shift is, because it shifted only pi eighths. But I can figure, since this is 2, and I divide I divide c divided by k divided by 2, then it's going to change that amount right there. It's going to divide it in half. And so if it's pi h, you double it, and you get pi fourths. So you can just play around with a few numbers until you get it. Huh? Which number? This part? Hey, you guys, let me give you a short answer to this. How do you find this number right here, the negative pi fourths and positive pi fourths? I would play around with it. I would just try numbers. Remember, I'm always going to put in, I'll either put 0, which there won't be anything there, or I'll put pi fourths, pi 6, any of the common ones is what I'm going to put in on the unit circle. Yeah, pi 6, pi halves, pi fourths, pi thirds. I could do 2 pi thirds too. Anything in the first and second quadrant I can do. Okay? Just really quickly. Guys, we are going to study the first half hour of class. We're going to review the first hour of class. I would suggest, I didn't get time. I told the other class I'd do this. I'll give you, maybe I'll add to this after you guys leave right here. And I will, if you want to watch the video, I'll give you some suggestions on some things you can study, okay? I'll add it to the video. For tangent, y equals tangent of kx minus c plus h. So it can be that one. For the other ones, like a sine of kx minus c plus h, you're just going to have an a in amplitude, right? For a cosecant or a secant, I probably won't put an amplitude either. It's probably just going to be something like the cosecant of kx minus c plus h.
My problem on having them
Those are the formulas.
is the other formula to get from phase shift. Oh, wait.
Phase shift. Oh, those formula?
Yeah.
So phase shift formula is equal to c over k.
Yes.
And period equals 2 pi over k for sine, cosine, cosecant, secant. For this one up here, period is equal to pi over k for tangent and cotangent, okay? You got to remember that. Does that help you out? Yeah, go ahead. Okay, for those of you who want extra stuff to study for the test, you'll want to go to page, I guess I should put the page number down, 414. And these problems on the test review, I suggest you do. Circled in blue. And you should know how to do all those also. If you want to study the angular and linear velocity formulas, they're quite simple formulas. I'm going to put an extra credit problem on the test like those. And those are like 21 through 28. They're just simple formulas if you want to look over those. And you might be able to get some extra credit. Also, I'm going to do a couple of problems right here that we didn't get a chance to do in class. I am going to talk about this one right here. I'm going to bring up my calculator. And I'm going to make sure my window is correct, negative 2 pi to positive 2 pi, pi fourths, negative 5 and 5. And I am going to try and find the function of that graph. Well, I can see, if I'm looking at this graph right here, that here's 2 pi. So that's, this right here is pi fourths, pi halves, 3 pi fourths. I believe that's pi right there. And if you look right here, there's an asymptote right there. And if you can see, there's been about, if I use a different color, there's 1 cycle, 2 cycles, 3 cycles that take place between 0 and pi. And that is, 0 to pi is the regular, pi is the regular period for a tangent function. So I would say that k is equal to 3 because there's 3 cycles that take place between 0 and pi. So I'm thinking that this function right here, and by the way, it's a decreasing function, so it's going to be a negative tangent function. It's going to be 3x. And it's actually been shifted some way. And I'm going to play around with the calculator to see if I can get the right shift. So if I go to my y equals screen, and I do negative tangent of 3x, I'm going to first of all see if that looks right. Okay, I need to shift it to the right or left a little bit. And I'm just going to play with it. Remember, the amount I shift it is always going to be one of these right here. It's either going to be pi 6, or pi fourths, or pi thirds, or pi halves, or 2 pi thirds and so forth, 3 pi fourths, and 5 pi 6, or pi. It will be one of those. So it's got to be shifted, one of those. Well, it's not shifted a whole lot. Okay, so phase shift is equal to C over K, and we got to figure out what C is. K is 3, so I'm going to guess I'm going to try pi thirds first. No, I'm going to try pi 6 first. So I'm going to go back to my y equals, and I am going to go over here. I'm going to go minus pi divided by 6. And I'm going to graph that. See if that's looking about like it should. Not quite. It shifted it. If I go back here over here and look at this, I'm going to erase this. It's not crossing right up here like this. You guys can see that at home. It's not crossing the y-axis right there. So I need to shift it a little bit more. I'm going to try pi thirds. That does. So go back to my y equals. I'm going to change that 6 to a 3. See what that does. Even that didn't shift it. Let's try pi fourths. Still crossing up there on the y-axis a little bit. That one even looks like it did. Well, maybe we should try pi halves. I'm thinking that's it right there. It looks like it's crossing the x-axis in all the right places. And that's close enough that if you had that, I would give it to you. It's not crossing the x-axis up there. So that would be it right there. So my answer would be negative tangent of 3x minus pi halves. Okay, so we're just kind of using a guess and check right there. I'm going to do another problem. This one right here. Well, I know that has to be oh, by the way, if I go back to the last one, that one could have been a cotangent function. We could have put 1 over the tangent in there and shifted it. So either answer would work. But going down to this one right here, I know that that one is either a secant or a cosecant. I happen to know that a secant function, remember, the secant function and the cosecant function touch at their hills and valleys. So right there, and right there. I happen to know that a cosine function goes through 0, 1. And so it's going to touch the secant right there. So I'm going to use a secant, which would be 1 over the cosine, in my calculator. And it looks like to me that you only have one cycle. If you count that half of that one and that half of that one, you only got one cycle between 0 and 2 pi. So I'm thinking that this is going to be y equals secant of x k of, it's going to be 1/2 x. That's what I think it is. Hey, come here, you guys. Hey, I'm making your video for you right now. I feel like I'm talking to myself, but if you guys came in here, it'd make me feel up better. Okay, see you guys. Okay, we're gonna have to put in our calculator 1 divided by the cosine of 0.5x. Would be 1/2 x. Okay, so we have, that's looking like it's pretty good. I think we got it right there. So y equals secant of 1/2 x. So anyway, those are some of the problems that are going to be on your test. Here's another one. Find the function of this graph. Well, from the looks of that, I know it's going to be a sine or a cosine again. And I'm looking at this. There is only one cycle that takes place between negative 2 pi and positive 2 pi. That means between 0 and 2 pi, only 1/2 of one takes place. So this is y equals sine. I'm going to use a sine. Actually, cosine might, well, either one's just as easy. I'm going to shift the sine to the left because a regular sine function would be going up like this, right here. And so I'm going to shift it to this direction right here. And I know that this is going to be 1/2 x. And I'm going to shift it. It's going to shift. The phase shift is negative pi halves. And if I take phase shift as negative pi half, or negative pi halves is equal to c over k, and k is 1/2. Okay, that means I times both sides by 1/2. I'm going to get negative pi fourths, right? C equals negative pi fourths. So I'm going to put plus pi fourths right here. I was doing that in my head and I'm tired, so let's see if I get it right. Might not have. We have sine of 0.5 x plus pi divided by 4. I think that's it. The only difference is, oh wait, this has an amplitude of 2 as well, doesn't it? Forgot about amplitude. Okay, so I should have an amplitude of 2 right here. So, is that 2 or 3? I'm having a hard time seeing it. 2. Okay, so I'm going to go back here. Now I'm going to insert. Second delete button is the insert, and you can put in 2. We can graph that. See if that looks more like what we have up there. I think that's it right there. Okay, that is it. If you get back close to it, I give it to you. So that is the answer right there. Let's see if there's one more question you need to know. Yeah, arc length. If you remember right, make this big now. Given an arc with a length of 12 feet and an angle of 30 degrees, find the radius of the circle. We learned the arc length formula, which is S equals R times theta. If I'm given the arc length is 12 feet, so I'm going to put 12 in for S, which stands for arc length. I know the angle, but the angle for finding arc length has to be in radians, and right now I'm giving it 30 degrees, so I have to times it by pi. So I got to times by pi over 180 to change it to degrees, to radians. Okay, so that's going to be 3 pi over 18, which 3 will go into 18 6 times, so it's going to be pi 6th. So I'm going to have radius times pi 6. If I invert and multiply both sides by 6 over pi, let's cancel out, and I get R equals 6 times 12 divided by pi. And I'm going to go to my calculator and do that real quick. Six times 12 divided by pi. 22.92. 22.92. 22.92. What was this measurement in? Feet. So I got R equals 22.92 feet. There we go. If you know everything that's on that review, you should do well. Good luck with the test. Study hard.